Dear students, I have taught you a function which is increasing or decreasing. You know that if dy by dx is greater than or equal to 0, the function is increasing in that interval, and if dy by dx is less than or equal to 0, the function is decreasing. But listen here, my dear students, the given function may not be always be increasing. In some interval the function may be increasing, and in a different interval the function may be decreasing. For example, if you take this function, assume that y is equal to f of x be any function, and this is the graph of the function. This is the graph of the function y is equal to f of x. So this function reaches what's our maximum at the point P, which we call it as a local minimum, and the function reaches local minimum at Q. The condition for the function to attain local maximum is dy by dx is 0 and d square y by dx square is less than 0. At that point I shall call that point as x is equal to a. So at x is equal to a, the function reaches local maximum. So the condition for local maxima is dy by dx is 0 at x is equal to a, d square y by dx square is less than 0 at x is equal to a. In other words, f dash of x is equal to 0 at x is equal to a, and f double dash of x is less than 0 at x is equal to a. Clear, my dear students? So at x is equal to a, the function reaches maximum, and the condition for local maximum is dy by dx 0 and d square y by dx square is less than 0. Listen here, at the point Q, the function attains the minimum, which we call it as a local minimum, and the condition for local minimum is dy by dx is 0 and d square y by dx square is greater than 0 at that point, and I call that point as x is equal to what, sir? B. So at x is equal to B, that is at the point Q, whose x value is B, at the point Q, whose x value is B, the function attains the local minimum, and the condition for local minimum is dy by dx 0, d square y by dx square is greater than 0. In other words, f dash of x is equal to 0 and f double dash of x is greater than 0 at the local minimum. The local minimum is x is equal to b. Clear, my dear students? And let me do a problem. So the condition for local maxima is dy by dx is 0, d square y by dx square is less than 0 at x is equal to a. The condition for local minima is dy by dx is 0, d square y by dx square is greater than 0 at x is equal to b. Let me take a function, discuss the curve y is equal to x power 4 minus x 4x cube with respect to local extreme. Local extreme means it may be local maxima or local minimum. So what is my function? My function is f of x is equal to x power 4 minus 4x cube. What is f dash of x? F dash of x is differentiation of x power 4 is 4x cube, and differentiation of 4x cube is 12x square. Differentiation of x power 4 is 4x cube, differentiation of 4x cube is 12x square. F double dash of x, differentiation of 4x cube is 12x square, and differentiation of 12x square is 24x. For local maxima and minima, dy by dx is 0. For local maxima and local minima, dy by dx is 0. This is my local maxima, and this is my local minima. Both at local maximum and at local minimum, dy by dx is 0. So put f dash of x to 0. That is 4x cube minus 12x square is equal to 0. Take 12x square as common factor. If I take 12x square as a common factor, take 4x square as a common factor. If I take 4x square as a common factor, it is what, sir? X minus 3. So equating this to 0, this implies x is equal to 0 or x is equal to 3. On putting x is equal to 3 at f dash of x, case 1. When x is equal to 3, f double dash of 3, that is d square y by dx square. F double dash of 3, that is d square y by dx square. 24 into 3 square, 12 into 3 square. 3 square is 9 minus 24 into 3. 12 into 9 is 108. 12 into 9 is 108 minus 24 into 3 is 72, which is nothing but what, sir? 36, which is greater than 0. So d square y by dx square, that is f double dash of x at x is equal to 3 is greater than 0. This implies x is equal to 3 is a local minima. Is a local minima. Local minimum value means we have to put x is equal to 3 in the given function. Therefore, minimum value is for finding minimum value we have to put x is equal to 3 in the given function. So this is y is equal to 3 power 4 minus 4 into 3 cube. X is 3, so it is 81 minus 27 into 4 is 108. 27 into what, sir? 4. 27 into 4 is 108. So 108 minus what, sir? 108 minus 81 is what, sir? Minus 27. So minimum value, minima is x is equal to 3 is a minima. And y is equal to minus 27 is minimum value. Minimum value. Clear, my dear students? Now we have another value, that is x is equal to 0. When x is equal to 0, put in f double dash of 0. This implies f double dash of 0, that is d square y by dx square. That is d square y by dx square. 0, 0 minus 0 is 0. So d square y by dx square is neither negative nor positive. D square y by dx square is neither negative nor positive. Therefore we cannot say anything about the maxima or the minima of the function. So our test fails. So we cannot say anything about extreme values. that is local maxima, extreme values. Extreme values means local maxima or minima. So what's our, for finding local maxima and local minima, take the given function as f of x, find f dashed of x, find f double dashed of x, find f dashed of x, find f double dashed of x, put f dashed of x to 0. On putting f dashed of x to 0, I get two x values. The two x values are x0 and x3. I put x is equal to 3 in d square y by dx square. So when x is equal to 3, my d square y by dx square, that is my f double dashed of x is positive. Therefore x is equal to 3 is a local minima. For finding local minimum value, we have to put x is equal to 3 in the given function. Clear, sir? And if f double dashed of x is negative, then x is equal to 2 or x is equal to 3 will be local maxima. Similarly, at x is equal to 0, I put x is equal to 0 in f double dashed of x. I put x is equal to 0 in f double dashed of x. On putting x is equal to 0 in f double dashed of x, I get the value equal to 0. So d square y by dx square is 0 means it is neither negative nor positive. Therefore, we cannot say anything about extreme values, or we cannot say anything about the local maxima or local minima. Clear, my dear students?